This time we talk about a solid geometry problem, about the skew lines and then distance problem. This is a question talking about this diagram. Point N is the center of the square ABCD. ECD is an equilateral triangle. The plane ECD perpendicular to the plane ABCD. M is the midpoint of the side DE. Which of the following statement is true? The first one, A, BM equal to EN. And these two lines are intersecting. B, EN and BN are not the same length, but they are intersecting in the same plane. C, BM equal to EN, and the two lines are skew lines. D, they are not equal, and also they are not in the same plane. They are skew lines. So what we can do, we're going to connecting EB and also DB. The N is the center of the square, so N will be the midpoint of the diagonal BD. EN is the meeting of this triangle BDE then. M is the midpoint of a DE, so BM also the meeting of this same triangle BDE. Since EN and BM both the meeting of the triangle BDE, so we're going to get their intersection lines. So we answer the first question. Second one, I'm going to find out their length. We're going to draw the perpendicular line EF perpendicular to DC. It is the height of the equilateral triangle CDE. We can find the height corresponding to the side. If the side length of a DCE is 2, we can find DF equal to 1. And so EF is square root 3. EF perpendicular to CD, FN also perpendicular to CD. The two plane perpendicular, so this is going to be a right triangle because this is exactly the angle formed for the two planes. The FN is equal to 1 because that's going to be the center. FN is half of the length of the square. The side length of the square is the same as the side length of the equilateral triangle. So FN equal to 1. And then we can find the EM by Pythagorean theorem. FN is 1, EF is square root 3, so FN equal to 2. This is also going to be 30, 60, 90 triangle, actually. 1, square root 3, this is 2. And then we're going to find the BM length. We'll do the same thing, draw a perpendicular line MG to DC. Since this is a plane CDE perpendicular to ABCD, so that means MG will be perpendicular to the base as well. So MG will be perpendicular any line inside the plane. So therefore, MG will be perpendicular to GB particularly. So BMG is a right triangle. MG is mid-segment of this triangle DEF. That will be half of the length of EF. So we're going to get half of a square root 3. In triangle BCG, that's also right triangle. This is GG equal to 1 half. So GC is going to be 3 over 2. 2 minus 1 half. CB is the side length of the square is 2. So we can find out GB square equal to 25 over 4. And then we get the BM is equal to square root 3 over 2 square plus 25 over 4. 3 plus 25 is 28. 28 over 4 is 7. So we get the BM equal to square root 7. To this point, we get the two length, EN equal to 2, BM equal to square root of 7. They are certainly not equal. So we get the answer should be B. They are not equal, and also they are intersecting lines in the same plane. So that will be the answer.